Okay, we're back again on chapter 11, and this will be part 3. So how can we predict floods? Well, one thing we can do is to monitor streams, look at their levels. We could also look at past behavior of that stream. We could also anticipate floods of a given size in a certain period. Like if we know the water level's going to be high in the spring, what can we do to prevent that river from flooding in the spring? All of this work, especially the anticipation of floods, is done by the U.S. Geological Survey and as well as our state agencies to come up with records on flooding in a particular river. So we have what's known as a drainage basin. So a drainage basin is the area that is drained by a stream or river. Those drainage basins are separated by a drainage divide, which is basically a high point. So you can see this black line that goes from top to bottom. That is what's known as the Continental Divide. Your Continental Divide runs along the Rocky Mountains. It separates water from the Pacific Ocean, the Gulf of Mexico, and the Atlantic Ocean. So Atlantic water, Gulf of Mexico water, can never merge with the Pacific Ocean because of that Continental Divide, that high point that prevents it. We do have different types of drainage patterns, and these are our 5 types of drainage patterns that we're going to go into. A summary of the pictures of the different types are shown at the bottom. So let's start off with a dendritic drainage pattern. Well, dendritic refers to tree-like, and tree-like in meaning that it branches like a tree. It's going to be the most common pattern, and you're going to see a dendritic pattern on gently sloping surfaces that all respond in the same way to erosion. And you can see this picture. It looks like the branching of a tree, all the network of channels that are funneling into that main river. A rectangular drainage pattern is basically when you have right angle bends. So your tributaries, your smaller streams, are going to join the larger ones at right angles. This usually happens when you have pre-existing joint structures, and those joints intersect at right angles. So a joint is basically a crack that has no displacement. A trellis drainage pattern is going to happen when you have a parallel main stream and you have tributaries branching off of that main stream. The trellis pattern will happen when you have alternating ridges of resistant rock and valleys of easily eroded rock. Notice your main stream goes through the easily eroded areas as well as your resistant rock. Your trellis pattern only develops in your easily eroded areas. So it resembles a trellis that you might put in your garden for a vine to grow on. But remember, this can only happen in areas where you have both that resistant and non-resistant rocks. The radial type of drainage pattern is when your streams are going to flow outward from a central high point. And this picture shows a good radial pattern on a volcano. And that is typically where you're going to see that radial pattern. We see a lot of that in the Cascade Range out west. And then finally we have what we call a deranged drainage pattern. That is one that's characterized by a very irregular pattern. You typically will see that when streams flow in and out of swamps or lakes. You have a large swampy area. So basically we believe this type of pattern is not a fully organized system. One place that you can see this type of system is where your glaciers have receded, your continental glaciers. So what's a base level? So base level is the lowest level to which a stream or river can erode. Now we only have one ultimate base level, and that is sea level. The exception being for streams that end in closed depressions in deserts. You can have multiple local base levels, but only one ultimate base level. So you can see in this picture, anytime you have a lake or another stream, it could be a localized base level. Here you can see we could have a localized base level right here. But our ultimate base level, the lowest level that we can erode, is going to be sea level. A graded stream is one that has a very smooth, concave, longitudinal profile. And the reason it gets this profile is because you have a combination of erosion and deposition. What we see is a balance between some of the features we talked about earlier in this chapter. A balance between gradient, which is, if you remember, the slope, the discharge, how much is passing a given point in a given amount of time, flow and velocity, channel shape, sediment load. So with a graded stream, being that there's a balance, there's not going to be either significant deposition nor erosion. It's going to be a balance between those two features. So when you think of valleys, valleys are linear depressions that are bounded by higher areas such as ridges or mountains. We get valleys from erosion of running water. Gullies, on the other hand, are your steep-sided, and they're small. Canyons are very steep walls, and they have deep valleys. A gorge would be a narrow, deep canyon. So in picture A right here, what we're looking at are gullies, very small, steep-sided valleys. Okay, and then in picture B, you have a valley and the walls extend to this narrow bottom that you see right here. So how do we go about getting a valley? Well, a valley first is going to start off as a rill. A rill is that first indication that you're going to get that valley. And then you're going to have what's known as down cutting. So down cutting is going to occur when that erosion happens. Basically, your stream is going to have more energy than needed to transport sediment. So it's going to erode downward. You could also get some lateral erosion, and that's going to happen when your valley walls are undercut. You're going to start to get mass wasting of that material falling in. You would get headward erosion, and that's going to be your erosion from runoff at the upper end of the stream or valley. The headward region is always the upper region. And then your stream piracy is when you have breaching of a drainage divide. Okay, so if we look at this first picture, A, we see that the stream is widening because of lateral erosion and mass wasting. Notice how you can see how it starts to get bigger because of that widening. In picture B, your stream is continually to widen. You get a lot of headward erosion, and you also have stream piracy happening. Notice your stream is breached this area right in here. Some other features we see are what's known as a stream terrace. So a terrace is a pretty flat area. So a stream terrace would be when you have a remnant of a floodplain or a floodplain that formed higher up when that stream flowed at a higher level. Your flat upper surface is going to have steep slopes toward the stream. You are going to have erosion episodes that occurred before the formation of your floodplain. And the stream terrace, you're often going to see it caused by changes in base level. So in this first picture in A, we see a stream that has a very broad floodplain. Remember, our floodplain is all this area on side and bordering our stream. Then in picture B, you see our stream has eroded downward and we have a new floodplain at a lower level than we did in picture A. In picture C, we have another level of our terrace being formed as your stream continues to erode. So here we have a terrace right here. In this picture, we have a terrace here, and in this picture, we have a terrace here, and a terrace there. So my check marks indicate the different terraces due to erosion. You could also have what's known as an incised meander. That is when a deep canyon is cut into the bedrock and it meanders. So basically you started off with a meandering stream that flowed through that alluvium. You have uplift to raise the area, and then your stream cuts down through your bedrock and you get the incised meanders. So you can see how this meander is very much down deep. It's cut down into the bedrock, and this is actually the Colorado River. Lastly, we can have what we call superimposed streams. So these are streams that once flowed at a higher level. They've been eroded downward into your resisting rock, and they cut a canyon. The canyon is then called a water gap. So a water gap is basically a gap where your stream was diverted. Usually that diversion happens through piracy. So in this first picture in A, we see that stream eroding downward through our rock layers. In picture B, notice the narrow valley that has formed through the ridges. And those narrow valleys are your water gaps. And then in picture C, you see that gap right there that's been cut. This is actually a picture from Montana. Okay, this ends Chapter 11, Part 3.